Never got
Yeah,
a letter.
assume
Never
is equally.
You never got a letter.
Evenly.
You never got a letter into
Well, the
number.
formula period is equal to 1 over frequency work then?
Uh,
Should that still hold?
Yes,
Okay.
in this case, because I already. You assume that the copying is because in the real world, right? So if you try to do it like that way,
Mhm.
but you can do, for example, you can do like our class, right, per week, but it can have different patterns. So we actually assume sometimes that we want to measure it in a simple way. We simplify this complexity into the periodic signal. Just
Okay.
imagine that you try to clap evenly.
Okay.
Yeah. We should move on with the solution. Okay, so you can do it later on. Try to get that frequency of your clapping. Okay, so solution. Okay. So convert your student number. We should all start with a 0, 2 0 0 3 0 0 4. So something like that. So I just use a very simple line and 2 0 0 3 0 0 4 0 0. So to convert that into how many binary bits you have to convert them into binary, and then how many bits that we got to be 28 bits. Okay, so hopefully you all get it. So the next question is so this one you can use calculator. Okay, so the next one is how to convert the binary bit you get from your calculator into hexadecimal, not just a push set factor. So you know how many bits we have in binary now, 28 bits. So we learned that for every 4 binary bits, it can be converted into 1 digit of hexadecimal. So that should be easy. Divide this by 4. So 7 hexadecimal bits we need to represent our student number. So your unique student number can be represented either by 28 bits of binary, or how many bits do we have in decimal? 9 decimal bits, or 7 hexadecimal bits. So hexadecimal is useful because we use less number of bits to represent the same information, the same value. Okay, so third question, a red light is flashing periodically for 0.3 seconds on and 0.2 seconds off. So what is the duty cycle? What is the duty cycle? Duty cycle is defined as a time that signal is high over the period capital T. So the period of it should be when the signal is high plus when the signal is low. So together we have 0.5 seconds. So the duty cycle is 60%.
Do we always assume on the signal high?
We don't
How do we know?
unless, but in general rules we do this.
Okay, so if it doesn't state it, assume on is high?
Okay, so unless it's otherwise stated.
Okay.
Yes, because we in electronics we have general rules.
Mhm.
Unless it's otherwise stated, what do? We follow the general
Okay.
rule.
The general
Okay.
high is on.
Yeah,
Like,
very good.
for example,
Max, right? So
Yeah.
Max is
if
very
the
good.
signal is by default is low, so
Yeah, by default. So most of the time, if it's not stated anywhere, so we know we have to assume something. That should be the common rule. So what do we get most of the time? Right? So that's a very good attitude as an engineer. We have to be very precise at all times So make sure that other people understand that our design as well. Very good. Okay. So the last question was to collecting. Okay, so it should be the reason was to clap for 10 seconds, not 1 second. It's exactly related to the question Max asked me earlier on. So do we assume that the clapping is evenly distributed? Yes, we do, because it can't be. We know that we can't do like perfect, evenly distributed clapping. So we do that for 10 seconds. That's long enough for us to average our clapping to get a reasonable frequency or period for our clapping. Okay, so it's like when we measure our heartbeat, how long do we normally measure? We measure it 60 seconds, 1 minute, right? All you can do is like 30 seconds. But why don't we measure 1 second? Because it's not going to give us enough information within that little period of time. So later on, we will learn the sampling frequency. We know to capture some information, we have to allow ourselves with the fast enough sampling frequency to capture enough information in the data. So that's welcome to the digital world. That's how we're going to treat all our signals, analog signals, and then convert them. So let's say we have 60 claps per second, then 6 claps per second, that is 6. So that's the time period is the period is 1 over frequency, that's 1/6. So you got it there. This is an example. For your case, you have to count your claps. So work out how many you got. So some of us are faster, some of us are slower. So that will be slightly different. Right. So let's move on with our chapters 2.